So let's try to solve some quadratic equations by factoring. Some of you may be able to do this just by looking at it. I'm going to try to come up with two factors that multiply out to 0. We need two numbers that multiply out to 6. So we could have 1 and 6, -1, -6. Could have 2 and 3, -2, -3. But the deal is, not only do they have to multiply out to positive 6, they have to add up to a -5. Some of you may be familiar with this method, where we take a times c, 1 times 6. Down here is the b is -5. And we need two numbers that multiply out to positive 6, add up to -5. It's the same reasoning. This is going to be x times x. So what are two numbers that will multiply out to positive 6? We got all the possibilities here, and add up to -5. Well, looks like only the -2 and a -3 will work. Now, because this is just a 1x squared, we can go ahead and make this x minus 2, x minus 3. And if they multiply out to 0, that can only happen if x minus 2 equals 0, or x minus 3 equals 0. So x will equal 2, or x can equal 3. Which means we have two x-intercepts. The parabola will cross the graph at the point 2, 0. We'll cross the x-axis at 2, 0 or at 3, 0. So that wasn't too bad. Now this one we can try, except it has a 6 out front. So we could do that. To multiply out to positive 6, you could do 1 and 6, -1, -6, 2 and 3, -2, -3. And at the 15, we could do -1 and 15, +1 and -15, 3 and -5, -3 and +5, and mess with these till we get a good combination. Or we could go right to the x. A times c will be 6 times -15, -90, and the b is just 1. So we need two numbers that are going to multiply out to -90 and add up to 1. Well, 9 and 10 are only one number apart, but we need one of them to be negative in order to multiply out to -90. Since they add up to a positive 1, the 10's going to have to be positive, the 9 would have to be the -1. So far, this may seem very familiar to you. Now, if this was a system you've used in the past, the next step would be that we carry down the 6, put a 6x here, put a 6x here, bring over the 9 and the 10, and then divide out a common factor. I'm going to do it differently. This is a little bit of a shortcut. Because we multiplied by 6 here, this wasn't just a single x squared like it was up here. Because we multiplied by 6, these numbers are 6 times bigger than they need to be. And we are going to compensate for that. Because we multiplied by 6, we are going to compensate by dividing both of the numbers we came up with by 6. And instead of putting a 6x here and a 6x here, we're just going to put x. And bring over the numbers that we came up with after they were divided by 6. So we'd have x minus 9 over 6, x plus 10 over 6. And those are our two factors. So either x minus, and I'm going to reduce them, equals 0, or x plus 5 over 3 equals 0. So either x equals 3/2 or x equals negative 5/3. We would have two x-intercepts. Now these are a little messy, so maybe we should trick them with the quadratic formula. Oh yes, let's check them. So if we're going to use the quadratic formula, a is 6, b is 1, c is negative 15. So x will have to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alrighty, so negative 1 plus or minus, well, 1 squared. A negative times a negative is going to be a positive. 6 times 15 is 90, times 4 would have to be 360 over 2 times 6. So x equals negative 1 plus or minus the square root of 361 all over 12. Turns out 361 is a perfect square. This is negative 1 plus or minus 19. 19 times 19, believe it or not, makes 361. So x will equal negative 1 plus 19 divided by 12, or x can equal negative 1 minus 19 divided by 12. So x will be 18 over 12, which if we divide by 6 reduces down to 3/2, or x will equal negative 20 divided by 12. And if we reduce that by dividing out a common factor of 4, we get negative 5 over 3. Those are exactly the same answers we got with the factoring. I don't know which one you think is easier, but they do both work. Getting a little crowded here. How about we try number 3? By factoring. I'm going to go straight to the big X. A times C is going to be 4 times 25. B is negative 20. And we need two numbers that multiply out to 100 will add up to negative 20. I'm going to go with 10 times 10. That will multiply out to 100, but in order to add up to negative 20, they would each have to be a negative 10. Negative 10 times negative 10 is a positive 100. Negative 10 plus negative 10 adds up to negative 20. And I'm going to try it this shortcut way. Instead of doing as you may have in the past, by putting a 4x and a 4x, bringing over the negative 10s, and then simplifying each of these parentheses, I'm just going to go with x and x. Because we multiplied by a 4 to get these numbers, we can now compensate for that by taking the two numbers we got and dividing by 4. We multiplied by 4 here. To compensate, we divide by 4 here. And then those go directly into the parentheses. So either x minus 5/2 equals 0, or x minus 5/2 equals 0. X equals 5/2, or x equals 5/2. We have one x-intercept. Just one. They sometimes call this a double root, because the 5/2 showed up twice as a solution. It means that the graph isn't going to cross the x-axis, it will just touch it there at one point. And I haven't left enough room here for number 4. So I'm going to do number 4 on a separate piece of paper. Except that number 4 isn't ready for us to solve. Because if we solve a quadratic equation, we're trying to find the x-intercepts, which means the equation has to equal 0. We have to make this equation equal 0. Well, we can do that. Just add a 5 onto both sides. We could try factoring. A times c is 1 times 5. B is 3, negative 3. So we need two numbers that multiply out to 5 and add up to negative 3. And we could spend a lot of time trying to figure it out, but this is not factorable. So if we can't factor, we're going to have to go to the quadratic formula. Oh, yay. So A is 1, B is negative 3, C is 5, and X is the opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Yay! Sorry, all over. So X is 3 plus or minus, well, negative 3 times negative 3 is 9. Minus 4 times 1 times 5 is 20. So we have X is going to be 3 plus or minus the square root of negative 11 all over 2. Well, we can't take the square root of negative 11 in the real world. So there are going to be no x-intercepts here. We're going to have two imaginary roots. You could leave it like that. Some of you may remember from Algebra 2 that we could rewrite this as plus or minus I times the square root of 11 all over 2. So those are just some of the ways we can apply factoring and the quadratic formula to solving quadratic equations.